Hello everyone, I'm Tree and welcome back to another video for the series. And first of all, I apologize for not being able to upload two videos for the past 2 days. I went to church retreat and I was not able to study problems there and also make a video on it. So that's why today I just came back and I'm making a video. So please be understanding of my voice. I'm trying my best. This is like the best. Yes, so. And also today I actually wanted to try an IMO problem. However, I realized that in order to like fully explain IMO problems, even like short listed problems, I need more time to understand them and like fully investigate on them. So I actually wanted to share a insight that I recently gained. So because I'm currently studying more on inequalities, there is a relationship between Hölder's inequality and Cauchy-Schwarz inequality. I think most of you might know that Hölder's inequality is just a generalization of Cauchy-Schwarz inequality. However, I couldn't find any videos or any explanation on websites or like forums or any research papers even on derivation of Cauchy-Schwarz inequality from Hölder's inequality. So that's what I want to do today. So first of all, Hölder's inequality so I think it will be the first video and I'm honored to do that. I hope this is a great one for anyone who is studying more on inequalities. Yes, so let's continue. So for all a sub I, b sub I, and dot 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 g sub I, it can actually start from C, D, or like E, but I just wrote until C sub I to show that it works continuously. And then for all of them in positive real numbers, the following inequality is true. I will just write them because it will be quite a long one. Lambda A. I will define what lambda A, B, and C are soon. Plus B sub n lambda b, and we can continue until we get c sub 1 plus c sub n and lambda of c. This is always greater than or equal to a sub 1 lambda a, b sub 1 lambda b to z sub 1 lambda z plus dot 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 plus a sub n lambda a, b sub n lambda b dot 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 on z sub n lambda sub z. For all lambda I greater than 0 such that let me include greater than or equal to it. It still works. Such that lambda sub 1 plus we were using a and b, right? So plus lambda sub b plus dot 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 plus lambda sub z, they're all equal to 1. So this is Hölder's inequality, and I think most of you might know the Cauchy-Schwarz inequality. And Cauchy-Schwarz inequality states that which variables? I will just use x and y for alpha, beta. Alpha and beta are good ones too, but I will just use this. Sorry, this is not right. I think x sub 1, yeah. I think this is a great choice for the variables. This whole thing multiplied is always greater than or equal to square roots of. Never mind, why do we have square roots? I was suddenly confused with AMGM. I should not be, but don't worry, this video will be credible, I hope. Yes. So this is Cauchy-Schwarz inequality, and we want to drive our second inequality from the first one. And notice that The first one and the second one, it would just be the same if the second one has two blocks. So let's say that. So proof maybe, yeah. So let's say that lambda sub a equals lambda sub b equals 1 over 2. That means the other ones, it will just be zeros, so we can ignore them. Like anything to the power of 0 except for 0 is equal to 1. But for convention, let's say that 0 to the power of 0 is, oh wait, no, actually this is positive, so we don't have to consider that case. So because we know that this is true, we can rewrite this from our Hölder's inequality, 1 over 2 times b sub 1 plus plus b sub n. 1 over 2 is always greater than or equal to a sub 1, 1 over 2, b sub 1, 1 over 2, 1 over 2 plus plus a sub n, 1 over 2, and b sub n to the power of 1 over 2. Now, actually, I think there is something that we can do, and it's really clever. No, actually, not that clever. It should be quite normal to start thinking. Like, let's just say that x sub I is equal to square roots of. It's quite natural actually to think of it like this. Equals square root of b sub I. Then rewriting, we get x sub 1 squared plus plus. You will start to see the shape here, the power of 1 over 2. Oh my goodness. Times y sub 1 squared plus y sub n squared to the power of 1 over 2 is always greater than or equal to x sub 1 times y sub 1 plus plus x sub n plus y sub n. Oh no, what am I saying? Times y sub n. Now we're done. We can just square them. And we can square them on both sides because we know that x sub I and y sub I, they're all positive numbers. So we can square them. It doesn't create a problem. So we have x sub 1, y sub 1 plus plus x sub n, y sub n squared. And we have our left hand side like oopsie, like this. And this is the exact same thing that you see right here. So that completes the proof. And I think the reason why I quite stuttered here when writing Cauchy-Schwarz inequality is because I usually think of Hölder's inequality first, and because that's more generalized form. And I don't use variables x and y usually for Cauchy, but I use them because I realized that we have to do this. So usually I'll use a and b here, and to avoid confusion I just use x and y, and that was the reason. And I think mostly in like Math Olympiads, including USAMO, KMO, and IMO, like Hölder's inequality and Cauchy-Schwarz inequality, they are like the most rudimentary inequalities that we should know, and it's also like the most common one. So I hope this video was fruitful, and tomorrow I will get back with another problems from Math Olympiads. So thank you so much for watching the video. If you like the proof or the derivation, actually this one I couldn't find them from other sources, so I actually had to prove it on my own. So if you enjoyed the proof, if you think there's any errors or anything else that you want to add, please feel free to write them on the comment box below. Thank you, and see you tomorrow. Bye.